Quicker than the actual construction of spacetime itself, it has the ability to keep up with its consciousness of it, and thus it will gradually dismantle this thought, filling me with a feeling of disquiet. Right now, our night sky is quickly changing, and within the next few decades, perhaps sooner, it could turn out to be totally unrecognizable. Specialists, including Neil deGrasse Tyson, are sounding the alarm, perceiving the inevitable changes brought on by the shifting of Polaris. The foundational reason behind this change is surprisingly unexpected. Polaris, commonly known as the North Star, has been a reliable feature in the sky for centuries, serving as a fundamental reference point for astronomers, pilots, and stargazers alike. However, this could soon be altered, affecting the way we see the sky and how we study the universe. For centuries, Polaris has been a guiding light for mariners and stargazers, standing firmly positioned in the sky. Its consistent presence has been essential for navigation, but this stability may soon be disrupted. A paper from the esteemed Royal Astronomical Society, published in September 2023, raised concerns about the future of this celestial marker. Polaris is entering a tumultuous phase, one where it could potentially explode, vanishing from sight forever and altering the sky as we know it. Before considering the potential outcomes of this event, let's delve further into the characteristics of the star itself. Polaris is distinctive due to its proximity to the celestial North Pole, located directly above Earth's northernmost point. It appears almost unmoving in the sky. It resides in the Ursa Minor constellation, commonly known as the Little Dipper. Polaris shines with a moderate brightness, resembling a yellow-white supergiant star that is much larger and brighter than our own Sun. However, Polaris is not just a single star. It is part of a complex triple-star system consisting of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational forces between these stars influence their orbits and behaviors, and disturbances in their interactions could cause shifts in their brightness or pulsation patterns. However, the exact nature of these forces is still not fully understood. Polaris is situated approximately 323 light-years from Earth, meaning the light we currently see from it began its journey long ago. If Polaris were to explode, we wouldn't witness the effects for over 300 years. It's even possible that Polaris has already exploded, but we have yet to observe it. Throughout history, the North Star has held significant cultural, navigational, and symbolic importance. Its fixed position has made it an invaluable guide for ancient mariners navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has been a crucial reference point in the study of celestial movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided vital insights into the properties of stars and the behavior of variable stars. This trait has also been key in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable rhythm, making its behavior easier to track. Recently, however, Polaris has begun to show signs of deviating from its normal behavior. This anomaly in its pulsation cycle has intrigued astronomers, prompting further investigation into the cause of these unusual changes. Rather than adhering to its usual pattern, Polaris has started to exhibit unpredictable dimming, leading to concerns that the star may be nearing the end of its life cycle. This behavior aligns with what is observed in stars approaching their final stages. The gradual increase in Polaris' pulsation period, when consistent, has been traced back to interactions within its star system. There has been an annual increase of around 4.5 seconds in the pulsation period. While this may seem insignificant, it carries significant implications. Some astronomers suggest that gravitational forces between the stars in the Polaris system could be driving these changes in its atmospheric conditions, directly affecting its pulsation patterns. Others are more concerned that Polaris is entering a critical stage that could lead to an explosion. The similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have shown complex variations in brightness, raising concerns that they may be nearing a dramatic explosion. Stars nearing the end of their life cycles often display such anomalies before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star approaches the end of its life, it goes through several stages, including the red giant phase and, eventually, a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the phase of helium depletion, which is typical for giant stars nearing their end. These irregularities align with patterns observed in stars nearing the end of their life cycles. However, strong evidence of an imminent supernova is still uncertain, and astronomers are continuing to monitor these phenomena to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a grand event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brightness could dramatically alter our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a significant role. Fortunately, Earth would likely remain safe whether or not Polaris explodes, due to its size and distance from us. While the explosion of Polaris might not be as visually spectacular as Betelgeuse, it could still be visible to the naked eye for an extended period, surpassing nearby stars. This would undoubtedly capture the attention of astronomers and observatories worldwide. The potential explosion of Polaris, while a fascinating scientific event, would have profound implications for our understanding of stellar life cycles. The data gathered from such an event would be invaluable for astronomers. Observing the supernova of a Cepheid variable star in real time would allow scientists to refine models of stellar evolution, understand the mechanisms of such explosions, and improve distance measurement techniques used in cosmology. Additionally, the loss of Polaris as a celestial guide would mark the end of an era. Throughout history, Polaris has been a cornerstone for navigation and orientation. Its disappearance would necessitate reliance on other stars or advanced technological systems for similar purposes. While modern GPS and other technologies have largely replaced traditional navigation methods, the symbolic importance of Polaris as a constant in the night sky cannot be understated. The cultural and emotional impact of such a shift would resonate deeply. Stories, myths, and traditions tied to the North Star would gain a new layer of poignancy, as future generations would only know it as a historical figure in the cosmos. However, this change also offers an opportunity for humanity to appreciate the dynamic nature of the universe, a reminder that even the most steadfast celestial objects are subject to the forces of time and change. Looking ahead, astronomers are keenly watching for further developments in Polaris behavior. Observatories worldwide are employing advanced telescopes and instruments to monitor its pulsations, brightness, and any signs of instability. The data collected will help determine whether Polaris is on the brink of a supernova or if its anomalies represent a more prolonged phase in its life cycle. As the scientific community prepares for the possibility of losing the North Star, they are also exploring what comes next. If Polaris were to disappear, another star would eventually take its place as the North Star due to the precession of Earth's axis, a slow, wobbling motion that causes the position of the celestial poles to change over millennia. Vega, a star in the Lyra constellation, is expected to become the new North Star in about 12,000 years. However, this transition would happen on a timescale far beyond human observation if Polaris were to remain stable for a while longer. In conclusion, the fate of Polaris is a reminder of the impermanence of even the most seemingly constant aspects of our universe. Whether it continues to shine for centuries or ends its life in a brilliant supernova, its story is a testament to the beauty and complexity of the cosmos. As scientists continue to unravel its mysteries, the lessons learned from Polaris will illuminate not just the mechanics of stars but also our place within the vast expanse of the universe. Producing broad interest both in the scholastic community and among astronomers, the impact on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet. But what will happen to Polaris itself? What is its fate after a potential supernova explosion? First, it's vital to note that while massive stars typically end their lives in a supernova explosion, this isn't likely for Polaris. When a massive star undergoes a supernova, its core collapses, triggering a violent shockwave that causes the star to implode. However, Polaris isn't massive enough to undergo such a dramatic event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition won't lead to a supernova but will result in a quieter end. Polaris will evolve into a small, extraordinarily dense stellar remnant. A white dwarf is the compressed core of a lone to medium-mass star that has spent its nuclear fuel. This remnant, although roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer observe Polaris as we know it. By comparing the effects of a potential Polaris explosion with those of actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate destinies. For instance, supernova events like SN 1987A, SN 2011FA, and SN 2014J have provided critical data that help us understand what might happen to Polaris in the future. For example, SN 1054 resulted in the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various wavelengths, providing astronomers with a rich field of study. Moreover, SN 1987A, which was observed in the Large Magellanic Cloud, offered fundamental insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries help us better understand the unique characteristics of Polaris. The formation of nebulae, like the Crab Nebula, occurs when material ejected during a supernova explosion interacts with surrounding interstellar gas and dust, enriching the gas with heavy elements and contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shockwaves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, researchers are studying the differences in the composition and velocity of ejected materials between Polaris potential explosion and other observed supernova events. By analyzing light curves, spectra, and remnants from these events, they can predict the potential outcomes of a Polaris explosion. This research will help determine whether Polaris explosion could lead to nebula formation or significantly impact stellar distributions. Another critical area of study involves the pulsational variability of stars nearing the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. Variations in the pulsations of stars nearing death might indicate internal instability or an imminent catastrophic event, offering valuable clues about the processes that lead to supernova explosions. Despite detailed observations and analysis, space experts are still puzzled by the inconsistencies in Polaris behavior. Understanding the causes behind these phenomena is crucial for advancing our knowledge of stellar evolution. The investigation into the factors causing Polaris irregular pulsations requires collaboration across various scientific disciplines and the development of advanced models and observational techniques. The potential loss of Polaris as a celestial reference point raises critical questions for astronomical research. Ground-based telescopes and measurements of celestial distances would require recalibration, affecting the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers, highlighting the significance of this event. The mysterious behavior of Polaris underscores the need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The disappearance or transformation of Polaris would mark the end of an era in celestial navigation and human connection with the stars. For centuries, Polaris, as the North Star, has been a vital guide for travelers, sailors, and astronomers. Its significance extends beyond science, deeply rooted in cultural myths, folklore, and human history. Modern technology, including GPS systems, has reduced reliance on stars for navigation, yet the symbolic and scientific value of Polaris remains profound. Its potential evolution into a white dwarf or other celestial remnant would present astronomers with an unparalleled opportunity to study the life cycle of a star that has held such historical importance. Detailed observations of Polaris transformation could provide insights into the late-stage behaviors of Cepheid variables and the underlying processes governing stellar evolution. Further research into Polaris irregular pulsations, mass, and chemical composition will also enhance our understanding of similar stars. Cepheid variables, like Polaris, play a critical role in determining cosmic distances through the period-luminosity relationship. Any changes in Polaris could prompt scientists to re-evaluate calibration methods used to measure the vast scales of the universe. Finally, the story of Polaris illustrates the transient nature of celestial phenomena. Even stars that seem constant and eternal are subject to the inexorable forces of change in the universe. This realization inspires both awe and humility as humanity continues to explore the mysteries of the cosmos.